Hey folks, welcome to my channel number pen. So there we have the problem on the screen. Integrate the following with respect to x. We have alpha beta x to the power alpha minus 1 times e to the power minus beta x to the power alpha. Right? Now looks like we have a very complex exponential expression, but I don't think it is as complex as it looks, right? So what we've been given is dy by dx and we've been asked to find y. So my y is nothing but integral of the given expression, right? So let's write down our y. So that's my y. And I know that I do not have this in a very simple format whose antiderivative I know from first principles or any of the identities that we've learned so far. Therefore, the job in hand is to simplify my y, right? Now let's see how do we go about doing that. I notice that I have an e to the power expression, and the expression in the power has got an x to the power alpha, right? And at the same time, I have alpha beta times x to the power alpha minus 1 as a part of this expression, right? So, can I connect the e to the power expression with alpha beta times x to the power alpha minus 1 part of the expression, right? The answer is yes. And how do I do that? I do that by making a simple substitution and then differentiating on either side, right? Now, this comes out of practice, and if you've not been able to arrive at the right type of substitution immediately, please do not worry about it. The more and more you practice, I think the sooner you will be able to arrive at the right substitution that you will make to integrate an expression quickly, right? So my t equals e to the power minus beta times x to the power alpha, my dt by dx equal to, I first differentiate e to the power expression with respect to the expression, which is nothing but e to the power expression itself. And then I go to the expression in the power of e. I have a minus beta times x to the power alpha, right? So when I do a d by dx of that, I get minus of beta remains as it is. So I will write my minus here, and my beta as well. I will put it across here, and then I get an alpha times, because I have x to the power alpha, my alpha is a constant, I have alpha times x to the power alpha minus 1. Means I can rewrite this as minus alpha beta. I pull out the alpha as well, and then I get my e to the power expression, e to the power minus of beta times x to the power alpha, and then I have an x to the power alpha minus 1, right? So this is my dt by dx, right? Which means I go to the next line, which means my dt equals dx times this expression, right? I go back to my y, I notice that the expression what I have in my y, which is nothing but a minus dt. Take a look at what we have for dt with us, right? I multiply by a negative sign on either side. Now let me highlight this in yellow. And what I have inside my y is also the same as what I have in the expression highlighted just now in yellow, right? And what is that? It is nothing but a minus of dt, right? So I have minus integral of dt, is nothing but minus t plus c, right? Now I know that I cannot leave my answer in terms of t. I'll have to put back everything in terms of x. I go to the next line, and what is my t? My t is the original substitution that I made, and therefore my y equal to minus of e to the power minus beta times x to the power alpha plus c. right? So now you see that the integration of this particular expression is not as complex as it looks like. Point here is choosing the right substitution to enable you to simplify the integration, right? So let me highlight my final answer in pink. There we are. I hope you found my content useful. Please do subscribe to my channel and support